Okay, this is lesson 6-6, and 6-6 is going to look at solving systems of linear inequalities. So you're giving one solution pair, and it has to work for both systems. So let's look at this equation here. We have -1, -3. Okay, this needs to work for both of these problems. Y less than or equal to -3x plus 1. Also, y less than 2x plus 2. Okay, so what we're going to do is set up these two problems and see if they're both solutions. And remember, it has to be a twofer. It must work for both in order for it to be a true solution. So I have y is less than or equal to -3x plus 1, which means my y answer, which is -3, has to be less or equal to whatever this side comes out. Okay, so let's go ahead and solve for that. I'm going to do -3 times -1, because that was my x value up here, plus 1. -3 times -1 gives me a +3 plus 1, which gives me a 4. So our final answer here, does -3 represent a number less than or equal to +4? Yes, it is less. So yes, so far that's a solution. Now let's see if the other equation also comes out a true solution. So we have y is less than 2x plus 2. What is our y? Our y is -3, and it needs to be less than whatever this side comes out to be. So I'm going to do 2 times -1, again, because that's my x value up here, plus 2. 2 times -1 gives me a -2. -2 plus 2 is going to give me a 0. So let's see if this reads true. Is -3 less than 0? Yes. So both of these work. So the solution set, -1, -3 is a true solution set. Let's try another one. We have -1 and +5. Is it a true solution set for these two problems? Y less than -2x minus 1 and y greater than or equal to x plus 3. Let's go ahead and plug in those values. What is my y? My y is 5. So 5 must be less in order for this to truly work. So let's try this. We have -2 times -1 minus 1. -2 times -1 gives me a +2. 2 take away 1 is going to give me 1. Is 5 less than 1? No. Now I could stop here, because once one of them becomes no, then automatically that's not a solution set and you don't need to move on further. So we're going to go ahead and leave it there. You could automatically just say -1 and 5 is not a solution. Okay, let's try this one here. We have a solution set of 0, 1. Y is less than -3x plus 2. And y is greater than or equal to x minus 1. What is my y? My y is 1, and we need that to be less. All right, well, let's plug in our x here, which is 0. Okay, -3 times 0 is 0. We have 0 plus 2, which is 2. Y is less than 2. Yep, that checks. All right, let's go ahead and do the other one. My y is 1 again, greater than or equal to. So 0 take away 1. Well, that's going to give me -1. Is 1 greater than or equal to -1? Yes, that checks. So 0, 1 is a solution. All right, now let's try one more before we get into graphing. I have a solution set of 0, 0. And we have y is greater than negative x plus 1 and y greater than x minus 1. Put in our value. 0 must be greater than whatever comes over here. So we would get negative 0 plus 1, which would be 0 plus 1, which would be 1. Is 0 greater than 1? No. So I'm going to stop there. I don't need to continue with that one. Y less than 3. How do you graph that? Well, there's no slope, which tells you it's going to be a straight line. And where is it going to pass through? It's going to pass through positive 3 on the y line, which is right here. It's going to pass through 3, which means the line, and it's going to be solid because we have an equal to, is going to go right through here. And of course, you're using a ruler, so it'll be a lot more straight. Okay, now this also says that y is less, which means our shading is going to go below. Okay, so I'm actually going to use my highlighter feature here for shading just to show it a little better. Okay, so when we shade, we just draw little lines. You don't actually have to shade it all in. You just need to know what part of this is being shaded. And I recommend using different highlighters because then you can see where the overlapping is a lot easier. Okay, so that's that first one. All right, let's go ahead and graph our second equation. Our second one said y is greater than negative x plus 5. Well, make that more like a 5. What is our y-intercept? Our y-intercept is 0, 5, which is going to be right here. 0, positive 5. And our slope is negative 1 over 1, which means down 1 over 1, which is right here. Now this is not, actually I should probably do both these dots in red, show as a different equation. It is not an equal to, which means it's going to get a dashed line. And I'm going to try my best to make sure I hit both these dots on my line. Okay, and of course when you're using a ruler, this will be a lot more precise. Something like that. Okay, now let's read it. This says that y is greater than, which means my shading is going to be above. Okay, so above the line, which means all this area here is shaded. All right, now what part of this is the solution? Well, the solution part is going to be this whole section here that they share in common, which is from here to here. This little piece is the solution set. Any number on this coordinate plane in this highlighted area is a perfect solution for those two inequalities because they both have similar areas here that they have in common. So we could pick any one of these spots and call it a perfect solution. We could even say 8, 1. Is 8, 1 in that solution? Yep, there is a point. We could say 8, 1. We could say 6, 3. There you go. 6, 3 would be a solution. What would not be a solution? Well, 0, 0 wouldn't be a solution. That only works for 1. We could even go as far as to say 4, 2. 4, negative 2. Wow, that's nobody's even in that area. Okay, so it's kind of like playing Battleship. You have to find what the area they both have in common and overlap. Okay, so let's try one more. Let's try one where you have to solve it first. Okay, get it into slope-intercept form. So here are my two equations. We have 3x plus 2y is greater than or equal to 2. And then we have y is less than 4x plus 3. Okay? Now, let's go ahead and get these in slope-intercept form, which means I'm going to move the x. So I'm going to add 3x to both sides. We want that y by itself. Remember, y equals mx plus b. So we get 2y is greater than or equal to 3x plus 2. Remember, always put the x first. Now we're going to divide by 2 because we want that y by itself. And when we divide by 1, we have to divide by them all. These cancel, and I get y is greater than or equal to 3 over 2x plus 1. So my y-intercept here is going to be 0, 1. So we're going to put our first dot there, and then we're going to go up 3 over 2. Let's go ahead and do this other problem over here. This one, wow, well, we don't really have to move anything, do we? What is my y-intercept? It's 0, 3. And what's my slope? Well, it would be 4 over 1, which means up 4 over 1. So let's go ahead and graph that then. Let me go ahead and pull back up my coordinate plane here. Okay. All right, first part we're going to graph is that 0, 1. So we're going to go 0, 1. It's right. Oops. Let's try that again. Okay, 0, 1 right there. And we were going to go up 3. 1, 2, 3, and over 2. 1, 2. So there's my dot. And if you remember, I'll write it again here just so you can see y is greater than or equal to 3 over 2x plus 1. Well, we have an equal to, which means we're going to get a solid line. And I'm going to try my best to make it straight. Okay. All right, now let's read it again. Y is greater than or equal to, which means my shading, getting my highlighter here, is going to go above. Okay, so this whole area above. All right, all of this. Okay, now let's do our other equation. Now that one we didn't have to work out. They kind of already gave it to us in slope-intercept form. So we have y is less than 4x plus 3, which means we're going to go 0, 3, right there. And then we're going to go up 4. 1, 2, 3, 4 over 1, right there. Okay, now this is going to be a dashed line because it's not an equal to, and I'm going to try very, very hard here to line this up. It's not really... well, if I had a ruler, it'd be a lot better. Okay, something like that. And of course, that's not even close to straight. But you get the idea. Take my other highlighter, my other color of your choice, and let's read this again. This says that y is less, which means it's going to go below the line, which is all of this area in here. And of course, if I had drawn that line a little better, it would make more sense. But what area do they have in common? With another highlighter, I'm going to highlight that area. This area right in here is what they have in common. Anything that falls in this section is a solution to those two problems. All right, well, I hope this helps you.